Hi, in this particular video we're going to be looking at the paper 2 for the November 2017 Edexcel Foundation paper. As always, please do stop the video, have a go at each of the questions and then compare your solutions. Each of the videos in the playlist is going to be about 20 minutes long. It's going to give you the opportunity then to have a go at each of the questions and spend about an hour's worth of fairly focused revision. If you do need any additional support, please don't hesitate to leave a comment. I'll always come back to you, or have a look on the rest of the channel, and there's lots of other videos with some more examples. I'll look forward to seeing you inside the video. Hi, this is video 2 in the playlist where we're looking at the November 2018 paper 2, and it's the foundation tier for Edexcel. In the last video we completed through to question number 16, so we're going to start from question number 17 onwards. As always, please do stop the video, have a go at each of the questions and then compare your solutions. So in this particular question we're looking at Adrian making some concrete, and he's going to use that amount of sand, cement and stone. He already has that amount of cement, sand and stone, and what bags he needs to buy. Okay, so a very typical question, even if it's a little bit wordy in the way that it's been put down, but I guess a bit more practical. So let's have a look and see what he's already got. So if Adrian already has, okay, so he's got 10 bags of cement, so he's already got 10 times 25 kilograms, so he's already got 250 kilograms of cement. Okay, he's got 20 bags of sand, which is 22.5. It is a calculator question, so please do use a calculator for each of these. It's absolutely fine. You're going to get 450 kilograms of sand. Okay, and then a bag of stone. Well, he's got 20 bags of stone, 20 times 50, so he's already got 1,000 kilograms of stone. Okay, so let's have a look. What does he need? Well, according to this, he's going to use 180 kilograms of cement. Well, he's got 250, so he's fine. 375 grams of sand, he's got 450, he's fine. 1,080 kilograms of stone, well, he's only got 1,000 kilograms of stone, so Adrian needs additional stone. Okay, and it says work out what bags. Well, he's going to need an extra 80 kilograms. Okay, now the thing about the stone is it's sold in bags of 50 kilograms. Okay, so he's going to need 2 bags, okay, which is equal to 2 bags. And that would be the answer to that particular question. Okay, hope that was all right for you. Let's have a look then at question number 18. Please do stop the video, have a go at it. And I'm going to aim for this video to be about between 20 and 30 minutes. So it should give you about an hour's worth of fairly focused revision. Okay, so Bill wants to increase 150 pounds by 150 by 3%. He writes down what's wrong with his method. Well, what's wrong with his method is that he's multiplied here by 30%. So 1.3 is equal to 30%. So 1.3 equals, if you like, 130%. So Bill has increased by 30%. Okay, if he wants to increase by 3%, okay, 3% would be 1.03 equals 103% to increase by 3%. Okay, now it's not actually asked us to write it down, I don't think, what that actually values out at, so it doesn't really matter. But either way, the problem with Bill's calculation is that he's used 30%, not 3%. Okay, so next bit of it, Sally wants to decrease 150 by 3%. Complete the statement to show how Sally could do that. Well, a 3% decrease is the same as a 97% of the original value. So 150 times 97% is what we're actually looking to do. Now, we can't do that on a calculator particularly easily. What we do is we convert it to a decimal, and 97% as a decimal equivalent is going to be 0.97. Okay, so it is worthwhile getting to grips with decimals and fractions and percentages in doing a lot of these calculations. So if you pop that into a calculator, you're going to get 145.5, and that would be the answer to that particular question. Okay, let's move it on to question number 19. So we're going to solve a linear equation here. So the first thing we're going to do is we multiply out the brackets by 3. So I've got 3x, and 3 times minus 4 is minus 12 equals 12. Okay, so what we need to do is get x on its own. We need to get x equals something. So the problem we've got at the moment is we've got this minus 12 here. So what I'm going to do is I'm going to add 12 to both sides. Now, if I do that, this and this cancel, I just get left with 3x. And on the right-hand side, I get 24. So I've got 3 lots of x equals 24. So if I want 1 lot of x, what I do is I divide by 3. Okay, this and this go, and I just get x equals 24 divided by 3, which is 8. So x equals 8. Okay, hopefully that's all right. Next one then, 19b, factorise fully. All right, just be real careful. They always say things like fully, okay? And what they mean is what are the common terms between 9b and 3b squared? Okay, well, the common factor of both of those with a number is going to be 3. So we can take 3 out. But we've also got to look at the letters. So we've got b and b squared. So the highest common factor of b and b squared is actually b. So I'm going to take that out and then open some brackets, and 3b times 3 will give me 9b, and 3b times minus b will give me 3b squared. So that would be, to factorise fully, would be 3b multiplied by 3 minus b in brackets. Okay, hope that's all right for you. Please be very wary when it says fully. They normally are 2-mark questions for that reason, that if you don't do the whole thing, then you'll just get awarded 1 mark. Okay, the other thing I'd mention is if you go to the channel, there's quite a few videos on factorisation, so please do have a look at some of those videos. Okay, let's move on then to a Venn diagram, which is question number 20. Venn diagrams didn't used to be part of the foundation curriculum, but they seem to have crept in fairly recently, so well worthwhile kind of working through these. So let's have a look at how we can complete the Venn diagram. Okay, so the universal set is even numbers between 1 and 25. So what I'm going to do is I'm going to write all of those down first. Okay, so I'm going to say 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, and 24. Okay, so I've got to account for all of those numbers somehow. Okay, so let's have a look then. So A is the set of 2, 8, 10, and 14. So what we've got within that set is also, as I mentioned, the number 8. Okay, but we've also got it in all those 3 as well. So actually, 8 occurs in all of them, the center set there. So we can get rid of 8. Okay, let's have a look then at A. Okay, well, A is going to be, the numbers that are remaining are 2, 10 and 14, and none of those are in either B or C. Okay, so let's look. We've got rid of 8 and we're going to get rid of 2, 10 and 14, but we're going to put them just into A. All right, let's have a look then at B. Okay, well, B, I've got 6 and I've got 20, but I've noticed that I've got also 20 in set C. Okay, so actually B and C have got 20 in both sets, and then B has got 6 on its own. So I'm going to get rid of that. 6 and 20, I've used those. Okay, last one is C. I've got 18 and 22. Well, 18 and 22 don't occur in all the others. Okay, so I've no problem with that. So I'm just going to put 18 and 22. I realised I didn't cross that one out. Okay, there we are. Okay, so what have I got left? Well, if we look at the sets of numbers that I've used 18 and 22. What we've got left is going to be 4, 12, 16 and 24. So that's this one, this one, this one and this one, and they will sit in the universal set 4, 12, 16 and 24. Okay, so it does take a little bit of time to work through these, okay, and it's just a little bit tricky. Just please do spend a bit of time. There are some playlists on Venn diagrams if you want to have a look at them, and you know, hopefully that'll give you a little bit of practice as well. And then it says a number is chosen at random from the set of numbers, the universal set. Find the probability that the number is a member of A and B. Well, there is only one number which is a member of A and B, which is this one here, okay? So it's going to be 1 out of, how many numbers are there altogether? Well, there's actually 12 even numbers. So if I count them up, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 numbers. So it's 1 out of 12. Okay. All right. So a little bit theoretical at the end there. It is 1 mark. You will come across it if you do a bit of practice on the Venn diagram type work. Well worthwhile kind of having a go. I keep saying well worthwhile today. I don't know why. Okay. Let's move on then to the next question, which is, I've seen this question before, I'm sure, on another paper. I mean, maybe I'm going a little bit slightly mad, but I've got a feeling I have seen this before, or something extremely similar. Okay, so Sean has plotted the points accurately. Write down 2 things that is wrong with his answer, okay, because he's been asked to draw a scatter graph and a line of best fit. So hopefully the obvious one first is going to be the line of best fit. Okay, so let's have a look at that. Line of best fit, well, it's going to go kind of more like that, isn't it? So I would say the first thing that's wrong is the line of best fit is incorrect. Okay, so let's have a look then. The next one, now this is a bit of a hidden one, okay? Now it is 2 marks for this particular question. You've just got to really look closely at it. But basically, it's the linear scale is not right, because this is a difference of 20 and then it's 10, 10, 10, 10. So actually there's a problem with this. Okay, this should be 150 if he was going to plot it accurately. So actually, let's have a look. So if I write on here the height scale is incorrect, should be 150 at 140. Okay, so this, I just make it clear to the examiner that you know what you're doing, and you know, that will award you those 1 mark for each of those. Line of best fit I think is fairly clear, but also the linear scale. Okay, hopefully that's all right for you. We're about 13 minutes into the video, so let's move on then. and I'm going to have a look at the next question. Okay, so this particular question deals with parallel lines, angles in parallel lines. It's okay, it's not too bad. What we've got to do is we're going to work out the angle of X. All right, well, the first thing I'm going to do is I'm just going to fill in the information I've got. Okay, because it just makes it much easier for me to, put together an argument for X, find out what X is if I know a little bit more about the angles. Well, I know that this line along here, so DEF, is a straight line. Okay, sorry about my writing. Okay, but DEF is a straight line. Now I know it's a straight line and therefore it's 180 degrees. Okay, so therefore angle what's that, BEG, so angle BEG must equal 180 minus 110 minus 25, so that's going to give me a value of 45 degrees. So this must be 45 degrees. Okay, so maybe that will get you 1 mark on the marking scheme. Okay, so let's have a look then at the next one. Well, the next one, which is parallel lines, and what you've got to kind of remember with parallel lines is either corresponding angles or alternate angles. Okay, so what we're saying here is that if this is 110 degrees, this one along here, then, although it's a little bit tricky to see it, I'll try and draw it on here. Okay, what it means is that this must also be 110 degrees, and that's angle CBE. So angle CBE is 110 degrees because they are alternate angles. Okay. Now, if you want to put on parallel line, that's perfectly fine as well. So this is 110, therefore this must be 110. Okay, so we can use that then to find out this top angle of the triangle, because it's going to be 110 take away 35. So angle EBG, okay, which is this angle. If I had a different color pen, I'd show you, but this angle here must be 110 minus 35. Okay, hopefully you can see that on the video. All right, so that's going to give you a value of 75 degrees. So now we have a triangle. Finally, we have a triangle where we know 2 of the angles. We know this top one is going to be 75 degrees, and we know the bottom left one is going to be 45 degrees. Okay, so if we want to work out X, I'll just draw this actually as a separate thing. So I'm going to draw this on the screen. So we know this is 45 degrees, we know this is 75 degrees, and we know this is X. Okay, so X must equal 180 minus 75 minus 45, so that's going to be a value of 60 degrees. Okay, and that actually is the answer to the question. So you might want to write a line that says something like angles in a triangle add up to 180 degrees. In fact, I'll do that just for the sake of completeness, as angles in a triangle add to 180 degrees. Okay, and again, just make it very, very clear to the examiner that you know what you're talking about. Okay, and hopefully you'll be all right with that one. Okay, let's move it on to question number 23. So please do stop the video. As I mentioned a little bit earlier on, compound interest and simple interest and all that sort of stuff does crop up with a lot of these types of questions. So this particular one, both accounts pay compound interest. So Ali invests £2,000 in a cash savings account, which is the first one, and Ben invests £1,600 in a shares. Okay, so what we've got to do is work out who will get the most interest at the end of 3 years. Now, you could, if you wanted to, use a table. I tend to prefer to use a formula, and the formula is equal to total, which is the amount he's going to have, is equal to original times multiplier to the power of n. Okay, and this is for Ali. And for Ben, it's going to be exactly the same. Now, what I would do is I would always write the same formula equal again. The reason I do that is because it clearly shows the examiner that you understand that it's still compound interest, but also it's great for memory. So the more you do these sorts of things, the more you'll find it much easier to remember the formulas. Okay, and again, if you go to the channel, there's quite a few videos on working with compound interest. Okay, so let's have a look at what happens with Ali. Well, he's got £2,000 original. Now, his multiplier is 2.5%. So in other words, what he's got is 102.5%, okay, as a multiplier, because with a compound interest account, the bank keeps 100% of the money, and then they add 2.5% on top of that. Now, we can't very easily calculate using percentage. So what we do is we change that to a decimal. And the decimal equivalent of this is 1.025. Okay, if you're not sure about how I've done that, please do have a look at the playlist on working with compound interest. So that's going to be 1.025, and it's the end of 3 years, so power of 3. Pop that in a calculator, and Ali at the end of 3 years is going to get 2153.78. Let's have a look to Ben, and we're going to do exactly the same idea, but this time his original amount is 1,600 and his multiplier is 3.5%. Okay, so it's going to be 103.5%. Hopefully you can see that okay on the screen. I'm going to convert that to a decimal, 1.035. So 1.035 multiplied by 3 years again. And at the end of 3 years, Ben is going to have 1773.95. Okay, so who's had the most amount of interest? Well, okay, I know there's more money in Ali's account, but he put more money in to begin with. And actually, his interest is going to be, if I just put on here, the interest amount is going to be 2,153.78. Take away the 2,000, which was originally his, and he's going to end up with £153.78 interest. So he's given the bank the money for 3 years. They've said, thank you very much. Here's £153.78. Ben's had £1,600, and at the end of 3 years, he's got now 1,773. So if I take that away from his original 1,600, the interest that Ben receives is going to be £173.95. So even though Ben started with a lower amount of money, he's actually earned more interest at the end of 3 years because he got a higher interest rate on his particular investment. So who will get the most money? Ben. Okay. Hopefully that's all right for you. Let's move on to part B of the question. Okay, so in the third year, the rate of interest for the shares account, that's the second one, is changed to 4%. Okay, so does this affect who will get the most interest at the end of 3 years? Well, no, it won't, because actually, poor old Ali is still going to get 2.5%. The fact that this has gone up to 4% just means that Ben will get even more interest. So I would just write something like that. Okay, Ben already has more than Ali and would increase by more. Okay, by more. That's not very good English. Okay, increase by more, but hopefully you'll get the idea. And obviously, in the pressure of shooting a video or something like this, these sort of things take a little bit of time to kind of work through. Okay, let's have a look then finally at question number 24, and then I'll probably stop the video at this point. So again, please do have a go at this particular question, and there compare your solution. So John is going to paint the floor. Okay, he's got a trapezium shaped floor. Oh, okay, all right. Don't know why, but he's got a trapezium shaped floor and he's going to buy some paint. So the first thing we've got to do is we're going to work out the area of the trapezium. So area of trapezium. Okay, now there's again a couple of different ways of doing this. You can either use a formula, which is the one I'm going to use, or you could, if you wanted to, break it down into kind of a compound shape. So you could have, you know, a triangle there and a triangle there, and see if you can figure out what these amounts are. It doesn't really lend itself to doing that because we don't know whether this angle is the same as this angle. So I would imagine it's probably safer and easier perhaps to use the area of a trapezium formula. Now the area of trapezium formula that I remember is a half A plus B times H. Okay, I have also seen it written as A plus B over 2 multiplied by H, or H at the beginning if you want to. Doesn't really matter. We're going to use whichever one. I'll use the second one. Okay, so A and B are the top is A, which is 10, and the bottom is B, which is 16, and then H is 7. Okay, so if I pop those numbers in, what I'm going to get is equal to 10 for A, plus B is 16, and then over 2, and then multiplied by 7, or times 7 if you like. Pop that into a calculator and that will work out as 91. So the area of the trapezium is 91 centimeters squared. Okay, so be very careful about that. Okay, all right, so each 5 litre tin of paint costs £6.99. Okay, and 1 litre of paint covers an area of 2 meters squared. Okay, so if 1 litre of paint covers 2 meters squared, then the amount of paint would be equal to 91 over 2, because 1 litre covers 2 meters squared. So we actually need 45.5 litres of paint. Okay, so how many tins of paint do we need? Well, if 1 tin is going to be 5 litres, okay, what we actually need is going to be, if I put amount of tins, that's going to be equal to, hopefully you can see this on the video, 45.5, and each tin is 5. So the amount of tins he's going to need is 9.1 tins. Okay, well, we can't buy 9.1 tins. We can't buy 0.1 of a tin. So therefore, we have to buy 10 tins. Okay, so therefore, each tin is going to be £16.99. Okay, so therefore 10 times 16.99 is going to equal to a total cost of, we move the decimal point 1 place, £169.90. Okay, so poor old John is going to have to think again or buy some cheaper paint, but unfortunately, no, not enough money if he only has £160. Okay, right, so a little bit of a tricky one to finish on there. Did take a bit of time, particularly if you're not sure about how to work out the area of trapezium, and I would try to encourage you to try to remember that particular formula and it will help. However, the good news is the next video will be relatively short because we've only got 3 more questions to go, but I think it would be worthwhile finishing there. So if you're not sure about anything, please do add a comment. I'll always come back to you. I'll look forward to seeing you inside the final and 3rd video where we're going to start from question number 25.